Hello everyone. So today I'm just going to show you that how Fibonacci works. Okay. So let me just show you about the Fibonacci. Okay. So let me just okay. So as you all know that how the Fibonacci just works. So it's like 0 plus 1, that's 1, and then 1, then 2, 3, 5, 8, 13, and these all things. Okay, so the thing is that how we are going to implement this thing on an FPGA. So I'm just going to show you. Okay, so here it's more clarified that how this all works. Okay, so first it is like 1, right? Then again the 1, then adding 2, so that's 2. Okay, then it's 3 and 5 and 8, 13, 21, 34. Okay, it's about the basic things. It's very much clear about when you are just showing through the arrows. Okay, so in an FPGA, I'm just using the DE1-SoC, that is for the Intel. You can run this thing by using Quartus Prime Lite, any version. So for that, what you have to do, you have to go to the device, okay, and make sure you are going to board. Click on the Cyclone 5, click here, and DE1-SoC board. Okay, well, I have connected this thing. You can just compare this with this. So like this one, so you can have the idea how I have connected each and everything. If you are not going to find this thing here, so you can just go here, and anything, if you are just going like, if you are going to Cyclone 4E Max 10, so you can connect each and everything here. You can find out the device number by going to the manual guideline of that specific board. Okay, so what I'm just going to do, I'm utilizing all the 7 segments here. Like you can just see, this is segment. Don't just get confused with the LEDs. It's just for the 7 segments. So 7 segment 0, 1, 2, 3, 4, 5. So total number are of 6. Okay, these switches are used for the values that are going to show us um, the output on the 7 segment display. Okay, so now we're okay, these all are I have just done with the data path. So like how it will just work. So here the 6 switches are used for the Fibonacci series. Now this is the FSM. FSM actually just do the calculation, and this done is just used for the like when the work is done. Okay, so if the work is done, so then you can just it will just annotate while on the output simulation that is done. And also I guess, okay, um, okay, so now these are all the connections of the inputs of to the 7 segment decoder. Okay, you can just see that how it just works. So each and everything, okay, the values are going to be in a hexadecimal, right? Okay, so these LED dips are just used for the done, like it will just show us the done. Now I'll just show you how it's working on the FPGA board. Okay, so let's move toward our next level on the FPGA comparison. Also, I'll just first of all, I'll just show you. Uh, I'll just show each and everything here. Okay, like you have any number. Okay, like 15 or 10, 11, anything. So we'll just go here. Okay, and then we will verify them on our FPGA board. So initially let's just calculate, as we are having by code, we just see. So we have the switches for the n value, that is 6. Okay, so for the 6 it's just like let me just show it to you. So it's like 2, okay, for the 1, 4 for the 2 bits, 8 for the 3 bits, 16 for the 4 bit, 32 and 64. Okay, so when we all add this thing up, so it will give us 64 number. Mean we can just go for the 64 number of series. Like here we can go 64, but not 64, we can just go for the 63, because we know that it just count from 0 to 63. Okay, so like suppose we are going to check for 25, so what it will be, the value, it will be 75025, right? Okay, now as I just told you that we are going to show on the FPGA in the hexa values, so let's convert from decimal to hexa, decimal online, right? So when we just convert this thing, so it will give us this value 12511. So I'm just going to save these all things. So on 25 the value is, so for the 25 you have to see what value you are just selecting up. So here in the binary, I'll just show you what the binary value is for the 725, that is this thing, right? Well, we are just not this. For the 25, this is 11. Okay, then the result we just came up was, so we are going to convert this into the hexadecimal. So the result was this. Okay, so result is this, and the result output of hexadecimal is this one. Okay, now we just see for the 10 value. The 10 value is 55. Okay, so 10 is very easy. So as we have 6, so 1010. Okay, so this is 10 value. Now the output is 55. So we can just check this thing out in the hexadecimal. So which will show us 37, right? So 37. Also we can go for another value, that is going to be for example 18. So let's go with the 18. So 18, which means that 010010. Okay, this is 18, and now the output is 2584. So now we are going to have 2584. Converting this in, it will give us A18. So let's verify these outputs on the FPGA board. So moving towards the FPGA board, so let me just show you what was the first value that we just assigned. Okay, so look, so the value is 1101. Okay, so let's assign 1 2 3 4 5 6. Okay, so 6 values, 1 1. No, I'm just getting wrong. Okay, 1 1 0 1. Okay, so this was 1 1 0 1. Okay, that is 1 1 0 1. Okay, so this one is a reset button. This one is some like the operation that just do that, no? So when I just click it, so look, it just give us 1 2 5 1 1. So what was the result? It is 1 2 5 1 1. Okay, so it's correct. Okay, just getting reset this thing value, this value. Now let's just see the 10 value, that is 101. Okay, so letting it down, so this is 1010. Okay, so when this, so it's the value is 37. So what was the value? 37. Okay, now let's just see, reset it. Okay, now let's just see the other, that one 10010. Okay, so when we just do this, so it gives us 8A18. So you can see the value is A18. So I have just show you each and everything, so you can get help from me anytime. You can text me. I have given my WhatsApp number, and also via comments on the video or email. You can just email me also. Thank you so much.